chemicals. It's really a very important, very pivotal and strategic subject for a region that has been a reliable supply of oil over the past 80 years. And when you talk about an energy transition that is happening over the next few decades, what is really the future of oil? And these are highly uncertain period. So that would be the subject of my today's talk. What could be the future of oil in a carbon constrained world, and how we really as oil can still play a pivotal role in meeting energy transition targets while also delivering the economic let's say economic targets of a region like Saudi Arabia, of Asian countries, China, India, and the whole wider global economy. So if we show the first subject, I don't know how much background you have, but let's assume that medium to high level. I assume here I'll have a few experts in the room. But how does what's happening now? What do the manufacturers do with oil once it is extracted? The first thing is that we are in a region that is one of the world's largest. Essentially, it holds one of the world's largest reserves in terms of hydrocarbons reserve, more than 270 billion barrels of proven reserves. And once oil is extracted, it says to make it as a fuel for anyone to use it, you need to send it to a refinery. So what a refinery will do, it will have a distillation tower, and based on variation in boiling points, you would get multiple fuels, starting from liquefied petroleum gas that can be used for your home heating or as a cooking fuel, and also moving to gasoline when the boiling rate goes higher to 30 degrees Celsius and above, and that is the fuel that you need to run your car. And then you could go higher to diesel, and the diesel that you may need for, I don't think we have diesel cars in Saudi, but definitely in Europe and in the US. And these are the heavy duty vehicles. Also, you may also be producing kerosene for jet fuels, and going up the carbon chain to get fuel oil for the shipping industry, and asphalt, the heaviest fraction of crude oil. So all of that, this has been done for the past, let's say, almost 80 to 100 years since the oil revolution started in the 20th century. So now with oil to chemicals, now the subject is oil to chemicals. Only about 8 to 10% of this process gives us chemicals, and that is pretty much naphtha. So naphtha has been the most important feedstocks for the chemical industry when we talk about oil. Yet, it is not just naphtha that gives you chemicals. In fact, most of chemicals are currently being produced from natural gas. Natural gas has been the major feedstock for the petrochemical industry in the kingdom. And back in the days, in the 60s and the 70s, when Jubail Industrial City was built, the idea was to stop burning gas and divert that to petrochemical manufacture. And that was actually a major part in the Saudi diversification in terms of its GDP. So right now, my whole point here is that we do produce chemicals from current refineries, but at a very small scale. Looking at the forecast, what we know is that, or what we are actually expecting, is that the future demand for fuels is for gasoline and diesel is expected to peak. And by the way, this is the most bullish forecast that is coming from OPEC. And as you may know, OPEC expects that oil demand is going to jump by 16 million barrels over the next 20 years. This has been the most bullish forecast compared to the IEA, which assumes an increase in demand by about 8 to 10 million barrels. So I'm here using OPEC forecast, and even OPEC forecast expects that there is going to be a peak in demand for gasoline and diesel by around 2040, 2045. On the other hand, we are expecting a growth in petrochemicals, and here at petrochemicals, this one. So from currently 14.29 million barrels demand, and that is expected to jump to something like more than 18 million barrels. So if you look at rough estimation, we're expecting to have an increase by about 4 million barrels in road transport, 4 million barrels in petchem, and another 4 million barrels in other industries and other sectors. So let's say 4, and that gives us 16 million barrels forecast for the whole sectors in the industry over the next 20 years. Of course, that means petrochemicals are expected to play a much bigger role in oil demand than what they are doing now. And what does that? This is a big business for oil companies, because right now Aramco exports oil to almost 56 oil refineries around the world. 80% of these refineries are in Asia, while 20% would be in Europe, in America, and other parts in the world. That is why we need to develop new technologies for chemical recycling. And I think here SABIC, Aramco are working very hard to fund research in this area. So now looking at the oil to chemical technology, what does it mean? So as I just mentioned, we produce something like 10% from conventional technologies. This can also be raised to 15 to 25%, but with oil to chemicals, you can get that to more than 40%. With ambitious targets, with new technologies like the Lummus technology, which is currently being partnered with Aramco, between Aramco and other manufacturers, this can go as high as 80%. Of course, here is this conversion is not straightforward. It requires multiple strategies. And I'm going to discuss what are these strategies that enable you to go as high as this. But as you can see here, you're converting your barrel from a fuel supplier into a chemical supplier. And that is pretty much a big business. Because as I understand is that the Kingdom targets as a part of the 2030 vision is to get as much as 4 million barrels of oil to chemicals by 2030. Currently we produce something like 10 million barrels, we export 7 million barrels, and if we can get 4 million barrels directly to chemical, then definitely we can leave part of that for fuels. So it can be really, it's sustained oil demand over the next decades as the demand expectedly starts to peak. Now, look at these multiple pathways, and every company has got its own pathway in terms of making this happen. With conventional routes, you can get a refinery, as I just mentioned, and you get naphtha. You send your naphtha to a steam cracker where you get very high temperature, high pressure steam that can crack your hydrocarbon molecules into light olefins, these alkenes, these double bond hydrocarbons. If you remember I'm going to remind you about basic chemistry now. So alkenes, you have straight paraffins. These are the straight hydrocarbons. Okay, but if you break the bond, then you're essentially going to form double bond alkenes. So these are the alkenes that are the basic feedstock to make chemical products, and these include polymers, plastics, and multiple other products. So steam cracker would enable you to convert your naphtha to olefins. These are the alkenes. So this is using a conventional crude oil, but you could convert oil directly using a steam cracker if you have very light oil. And pretty much this is a business in the US, because in the US they have very light oil, including the shale oil produced from Texas and multiple other regions. And that is very light to be converted. And that's why the US is pretty much has enough gasoline. And even when they import from Saudi Arabia, they get the heavy oil, Arab light, that is medium sour. Okay, and what the reason is because refineries there need diesel. That's why they need to call on or to get at least something like 500,000 barrels from Saudi Aramco. But in terms of gasoline, the oil there is pretty much sufficient to produce that gasoline, because pretty much it is very light, and that means it burns. It gives you gasoline at a temperature between 30 to something like 90 degrees Celsius. And that's what we mean by very light. Very light means low density and low boiling range. If you get a mixed crude, like when you are in China, then a crude to a paraxylene complex, and paraxylene is another form of aromatics, not really olefins, but these are also forms to produce other forms of chemicals using certain refining configuration, which I'm going to elaborate on in the next slides. Also, here with Aramco and SABIC, light crude, light Arab, Aramco produces something like 5 million barrels of this type of crude from the kingdom, and using certain technologies, they can get that to olefins. Then you could use a new technology like the high severity FCCs, FCC, and with that temperature, it essentially runs at slightly much higher temperature rate. Like this is the one in Korea, and you could get that as high as more than 40%. In fact, even it's expected to go as high as 70%, including multiple products, that is propylene, benzene, and multiple other products. If you would like to become even more sophisticated, converting your crude directly to chemical by passing the distillation stage, which you need in the previous two processes, then you could say, okay, we'll invent a new technology by converting oil directly into chemical. So instead of taking your oil to a distillation tower, you bypass that step, which saves you cost, and send your oil directly to a steam cracker or other types of hydrocracker. And that would give you, of course, here you need to use certain catalyst, and that is the chemistry behind this is very complex because oil is not a single component; it's multiple very complex components. And to get that, essentially you would be faced with carbon formation. This is one of the most challenges that is facing oil refiners. Essentially, when you raise the temperature while processing oil, you would start to form carbon, and these carbon pigments would block your catalyst, and that would reduce your overall efficiency, and that creates an operational challenge. Yet, at KAUST, and here in Saudi Arabia, they've been successful. Of course, this is a very optimistic result. So they've been successful in directly converting crude to chemicals because they have invented a very special catalyst that enables you to do that. Yet, it's in a very small experimental scale. Whether that can be scaled up, definitely it needs additional and further research in order to scale up that. But they've been very successful in showing that the process can happen from a theoretical and experimental basis. Now, these are just some key markets where some plants are currently being built, already operational. So you'd see in Saudi Arabia, where there's a huge interest in this, whether in Jubail, in the western side. Also in the Emirates is trying to invest something like $45 billion in a crude to chemical projects. In India, Aramco is entering with 3 refineries there in order with a deal worth $46 billion. In Korea, they are already starting building $7 billion crude to chemical project. Also in China, where most of the plants crude to chemical are situated, either via starting new plants or constructing or entering through joint ventures. That is already happening in China, and I believe there is a deal. The most recent deal is more than $3 billion acquisition from Aramco and a refinery in Washington. Also in Brunei, in Korea, and pretty much in the Asian markets. Here is that Aramco has a clear incentive, because if you attend press conferences with the CEO of Aramco, they'd say, okay, we're going to, every time they publish the results, they say, okay, we're going to have more investments in the downstream side. And the reason here is that because essentially Aramco, if they continue doing that, essentially they can produce more chemicals than all steam crackers combined in the US. So they will have a very huge refining or crude to chemical capacity at a very affordable cost. So there is very much a economic incentive, because if you think about refineries have much bigger capacity than petrochemical plants, because world refining can process something like 100 million barrels. And if you consider that these refineries will be able to produce chemicals, then how much chemicals that can we actually have? So it can really be a big game changer for the petrochemical sector. Even here, just look at China in terms of the demand for its exports. So why would Aramco continue investing, as I just mentioned, and Why would China be a major player in terms of this market growth? Because expectedly, between 2023 and 2030, the demand for these products, paraxylene, ethylene glycol, and low-density polyethylene, and multiple other petrochemicals, will be, these are the exports, global exports. More than 81% will be in China. That is the paraxylene. And ethylene glycol, 66% of global exports, again, will be in China, and multiple other